Hello everybody, it's Dr. Polizio Gatto and welcome to this guide to biostatistics and epidemiology for medical board exams, as well as some random facts on cats. So this is a high-yield crash course in evidence-based medicine and random cat facts that you will find dispersed out throughout the course. It's specifically tailored for international board exams such as the PLAB, USMLE, MRCP, AKT, MSRA, etc. For the full video course, please visit the website here. I'm going to post a link also in the description, and if you just want the ebook, I'm also posted the description here, and I'm also going to post it in the video description at the bottom. To contact me, here is my email, drpoliziogatto@gmail.com. Alright, so this is part of a promo video for the full course. So in this course, we're going to talk about hypothesis testing. But just to let you know, this is essentially all that we cover in the whole course. So descriptive statistics, categorical tests, qualitative research, screening tests, epidemiology. It's full-on course, but then very high yield stuff that you're going to come across in your exams. All right, let's get started. So let's talk about hypothesis testing. Now, the two things you need to know when you're talking about hypothesis testing, the first thing is the null hypothesis and the alternative hypothesis. The null is basically the opposite of what you're trying to achieve, and the alternative hypothesis is what you are trying to achieve. So for example, you want to do a test on blood pressure lowering. So you get a drug, let's call it drug X, and then your hypothesis is that drug X lowers blood pressure, right? So this is what you're trying to prove. Because this is what you're trying to prove, this is called your alternative hypothesis, right? And so the opposite of this is that X does not, actually not even does not, X has no effect on BP. So that's your null. So remember guys, null is the opposite of what you're trying to prove, and the alternative hypothesis is what you're actually trying to, what you want your study to be. So X lowers blood pressure, that's your study, that's what you're trying to do, so that's called the alternative hypothesis. And the opposite of that, meaning X does not cause any effect on blood pressure, is your null hypothesis. Fine, so now that we've got that concept out of the way, let's talk about the next thing for p-values and confidence intervals. Essentially, to simplify it, if you want to forget everything else, p-value less than 0.05 means statistical significance. Right, so what exactly is the p-value? It's defined as a probability of observing the study result if the null hypothesis is true. What does that actually mean? If the p-value is less than 0.05, we reject the null hypothesis. So p less than 0.05 means reject null hypothesis. Essentially, it told us if there is statistical significance. If the p-value is less than 0.05, it means there is less than a 5% chance the results are due to random variation alone. And common cutoffs that are used are 0.05. If you want to be more stringent, a smaller threshold such as 0.01 could be used to make the evidence stronger. But generally speaking, for most studies, if you see this value, p equals to less than 0.05, means the statistical significance, means we reject the null hypothesis, means we accept the alternative hypothesis. All right, so that's the p-value. Now, what's the confidence interval? So the confidence interval is the range from the data likely containing the true effect size with a certain confidence. So for example, we typically use 95%, but you could also use 99%. But for most statistical studies, what you're going to find is a 95% confidence interval. So for example, drug X lowers weight. All right, so let's change it. So drug X is going to lower weight, and the weight loss difference could be anything, say from -2 to +2. All right, so what does this actually mean? Or say, so this is drug X, so this is one study, and let's say drug Y, the weight loss is 4 kg to 6 kg. Then drug Z, let's say the weight loss is anywhere between 1 kg and 10 kg. So you're given these confidence intervals, right? So these are the 95% confidence intervals that you're given for these three drugs. How would you interpret this? Now, what's important to note, first of all, is does it involve the number 0? So like in this case, drug X, right? 0 would be somewhere there if this is a number line, right? Remember your number lines from basic primary school maths, right? You've got your 0 there, you've got your 1 there, you've got your negative there. +2, -2, right? So this is negative, this is positive. As long as the confidence interval includes the number 0, you reject it. Okay? So for example, in this study for drug X, note that it goes from -2 to +2, meaning your patient could either have lost 2 kg or they could have gained 2 kg, right? So in this case, we reject the confidence interval because it includes the number 0. All right. So remember, anything that's going from a negative to a positive, you're going to ignore it. On the other hand, look at drug Y and look at drug Z. So 4 to 6 obviously does not include 0. 0 is going to be, if you're going to draw a number line, it would be somewhere there, right? So it's 4 to 6 kg, fine. So drug Y lowers weight anywhere between 4 kg and 6 kg, and drug Z lowers weight between 1 kg and 10 kg, right? So that's what we have. So we've got two confidence intervals here. Both drugs we're saying work. We're saying drug Y lowers blood pressure by 4 to 6 kg, while drug Z lowers blood pressure from 1 kg to 10 kg. Notice how the confidence interval for drug Y is narrow, meaning it's more precise, as opposed to this one, which is wide for drug Z, less precise, less accurate, if you want to use a different word. And how would you interpret this? What we can conclude from drug Y is that with this confidence interval, it lowers the blood pressure, it lowers the weight from anywhere between 4 kg and 6 kg. We're 95% sure it lowers it anywhere between this. Not 4 kg exactly, not 6 kg exactly, not 5 kg, somewhere in between. On the other hand, the same thing for drug Z. What we can conclude is that it lowers the weight with a 95% confidence. We can say it lowers it by anywhere between 1 kg and 10 kg. So it could mean, so notice how wide that is, meaning if you take this drug, there's a 95% chance you lose 1 kg or you lose 10 kg. So much wider confidence interval, meaning it's less precise. So, and remember, this means anywhere between 1 kg and 10 kg. So it could be 4 kg, could be 3 kg, could be 2 kg. We just don't know exactly where. So when you're trying to sell when you're trying to choose a drug, you want the one that has got a narrower confidence interval because it's more precise, 1, and 2, does it have any clinical significance? So for this, for example, drug Z, lowering weight by 1 kg might not be significant, right? If it's lowering by 10 kg, that might be significant. But remember, it's a wide variation, so we just don't know how good it is. So if I was to choose a drug from these three, obviously we know X does not work. Y, yes, it's better. Y sounds good, Z sounds good, but given that the more consistent weight loss with Y, I'd go for drug Y. Another thing to note is that sometimes you might have statistical significance, but you won't have clinical significance. So you have to look at the p-value as well as the confidence interval together. Don't look at them in isolation. So for example, you'll find a study will show the p-value is less than 0.05, let's say 0.02 or something, but the confidence interval will be, say, -3 to +5, right? So there's statistical significance, but no clinical significance. All right, so remember, look at these two as a whole and not in isolation to make any conclusion. So questions on this usually, sometimes it can be as straightforward as, what's the conclusion from this study? Did it show statistical significance or not? So if the p-value is less than 0.05, yes, it did. What was 95% confidence interval? If it includes 0, it is not statistically significant or clinically significant. A narrower confidence interval is more precise than a wider confidence interval. All right, I think I've basically just explained all of this stuff just now. So in summary, null hypothesis is the opposite of what we're trying to prove. The alternative hypothesis is what we are trying to prove. This is what we are trying to prove. If your p-value less than 0.05 means reject null. If your confidence interval includes 0, reject confidence interval. Basically no statistical significance. All right, guys, that's the first part of this video. The next part, we're going to talk about power and type 1 and type 2 error, which is important in hypothesis testing. But before we get there, let's end this talk with our cat of the day, which is the Siamese cat. So this cat originates from Thailand, formerly known as Siam. And the royal cats, considered sacred temple cats. And they're very easily identifiable with their striking blue eyes, white fur, and brown face and brown paws. They're very vocal cats, quite talkative, and very affectionate and social. They form quite strong bonds with their owners and tend to be quite clingy, following them around, seeking attention. They're one of the most intelligent cat breeds, and they're almost like dogs in a way, because they're quick to learn, and you can teach them tricks and play games. But because they're quite intelligent, they require quite a lot of stimulation to stay happy. All right, guys, let me know below if you have a Siamese cat. And see you guys all in the next video.